as advertised. Our goal today is to write the names and formulas of ionic compounds. Or sorry, of molecular compounds. So, whole new set of rules. So that our first decision is got to be, is it ionic or molecular? Once we decide it's molecular, then we have to do this. So, how are we going to recognize that it's molecular, not ionic? Made of just nonmetals. Click, but nonmetals are nonmetals and hydrogen. They're all the ones that did covalent bonding. Covalent bonding gets you molecular compounds. So just like you had to decide what kind of bond. It's not a new decision. They're just doing something different once we make the same decision. Once I decide that it's molecular, I don't show dots moving. I show them sharing. Once I decide they're molecular, I don't get to name them the same way. Smallest piece of the molecule, unlike an ionic compound where it's just a formula unit. All we can say is we've got to have so many of these for so many of those. But that gives us a problem. Because every time we wanted to figure out how many there was, we use the charges because the charges have to add up to 0. These don't have opposite charges. These aren't going to add up to 0. They both make negative ions, so nobody's making an ion, because neither one's giving up the electron. So you can't use charges to figure out how many. That sounds like bad news, doesn't it? But actually, no, it's good news. If they can't expect you to figure it out, they have to tell it to you. Just like we can't expect you to figure out what the charge is on a transition metal, they always tell you, either with a Roman numeral or by putting it in next to the ion. Okay? If they don't expect you to figure it out, they have to tell you, and that's going to be easier because all you have to do is change your name, so the name is just going to tell us how many there is. I mean, the name is going to be like 3 carbons, 8 hydrogens. Could you write the formula if somebody told you the name was 3 carbons, 8 hydrogens? It's pretty close to that. It's pretty close to that. Molecular compounds, the name tells you the number of atoms. It really comes close to saying 3 carbons, 8 hydrogens. But being scientists, being international, they are not going to write the word 3. They're going to use prefixes. So they're going to stick a prefix that means that number. So we need to know the prefixes up to 10. And there's a Greek list and a Roman list, and I forget which one this is. Okay? About half of them will be familiar. The other half you'll have to stop and think about. So here's the prefixes I need you to know. The prefix that means 1 is mono. Any problems with that? Does that surprise you, that mono means 1? The prefix that means 2 is di. What's the next one going to say? Everybody should know the next one. You should try, yeah. Four, they had a couple of choices. Okay, they could have used quad, but instead they used the one from math class that talks about shapes, which is tetra. Remember, tetra means four, tetrahedral, four-sided. Tetra means four. They call it Tetris because every shape has four blocks. 5. This is one you expect. That building in Washington with 5 sides. The Pentagon. 6. 6 is hexa. They could use the sexa or hexa. That's the Latin Greek thing. They picked the hexa. Hexagon. It's the ones you put agon after. How about 7? Anybody remember 7? We don't use it very much, so we forget it. Look, you're close. You got the right idea, but that's the other language one. If it's hex, it's hepta. If it's sex, if you use the one that's got the sex for 6, then it's septa. So that's like ages. Septuagenarian means a 70-year-old. Okay. 9 is nana. And 10, we're not surprised by. Deca. Oh, and they keep going. They keep going from here. We just don't need to know them any bigger than this. I mean, and the way they go is they add a number 2. So 11 is undeca. 110. 12 is dodeca. 210. 2 and 10. Tristeca. 3 and 10. So the fear of the number 13 is tristecaphobia. Yeah. All right. So those are prefixes. So that's going to tell us how many. So how do we write them? Well, to write the name, you will write 2 words. 2 words. So every name will be 2 words. First word sounds like, no. First word starts with a prefix. And then you write the name of that element. So if we can do 3 carbons and 8 hydrogens, that would be tricarbon. And second word, you put the prefix on. You take the name, but you change the ending to IDE. It's going to be a non-metal, so it wouldn't be surprised that we changed it to IDE. So 8 hydrogens there would be octahydride. So the name of something with 3 carbons and 8 hydrogens is tricarbon decahydride. Or, sorry, octahydride. I want to say deca. Octahydride. Okay, only a couple little exceptions. One, if there's only one of the first element, we don't put mono on it. So that first element doesn't get the prefix mono. It gets all the other prefixes, it just doesn't get mono. Because they figure that you can figure out without a prefix. It's not that you forgot the prefix. Okay, some of those elements, name starts with vowels. Okay, and we don't put A and O together. We drop the A. We don't put O and O together. We drop the O. But we keep the I's. So IO, OI. AI, and actually II. II should be on this list too. II is good. So if you had 3 iodines, you would say triiodine, 2 I's. Not triiodine, triiodine. To give you an example of something that follows this, what is the name of that chemical? CO2 is carbon dioxide. That's why they call it carbon dioxide, because its name is carbon two oxygens. Makes it pretty easy to figure out what the formula is. I taught you this one because you are not allowed to use prefixes on ionic compounds. That's where the mistake comes, is now that I taught you these prefixes, you're going to want to use them everywhere. But if it's ionic, it doesn't get a prefix. If it's got a prefix, it's not ionic. Okay? So, name this compound. N2O. So I want a name that says 2 nitrogens and 1 oxygen. So to say 2, prefix is di. First word nitrogen, I leave alone. And then we want to say 1 oxygen. So you want to say monoxide. What if you write monoxide, what does that look like? Monoxide, right? So we drop one of the O's. Monoxide. That's what the no double vowel thing's about. Everybody okay with that no double vowel there? Okay, compare that to NO2. See, I have 1 nitrogen, so I want to start with mono, but I never start with mono. So I'm just going to say nitrogen. And then 2 oxygens, dioxide. Pretty easy. About this time, somebody should raise their hand. Excuse me, Mr. Green, NO2? I've been doing my job. NO2 is nitrite. No, it's not. NO2 minus is nitrite. Without the charge, it's a molecule. With the charge, it's a many-atomed ion, a polyatomic ion. And that whether it has that charge or not makes a real difference in how it behaves. NO2 is a brown gas. NO2 minus is part of a solid ionic compound. It's actually the stuff that gives bacon and hot dogs their distinctive flavor. Nitrites. Okay. Cl2O7. They're easy to write, they're a pain to say. Okay? Di for 2, chlorine, and then the prefix for 7 was hepta oxide. No, I don't do heptaoxide. I do heptoxide. I keep the O because I keep that part of it. I'm keeping the part about the element. That's the important part. The A is unimportant in hepta. Dichlorine heptoxide. Yeah. Do you see Br4? I do, right there. So, 1 carbon, I can just say carbon. 4 bromines, the prefix for 4 was tetra. Bromide. Don't forget to change that ending. So notice we hit that "ide," we know we're done with that chemical. It's a clue in the name that says, oh, we're done talking about that chemical, we're ready for the next one. So you hit that "ide," you hit that "H," you hit that "ite," you're done with the chemical. It's an ending signal. BaCl2. So, of course, BaCl2 is barium chloride. No dye. It's barium chloride. Because we skipped step number 1. What is barium? Barium's a metal. Metals, we don't need prefixes, so we can't use them. I told you once, you see why I taught you the other order? Why did I teach you prefixes first? Because if I taught you prefixes first, you would use them everywhere all the time. I taught you not to use prefixes, now we can add them to our repertoire for molecular compounds. So your first decision is not, what is this thing's name? Your first decision is, what kind of compound is this? Is it ionic or molecular? Does it start with a metal or does it start with a non-metal? Everybody okay at that? I'm not trying to trick you. I told you ahead of time that this was the challenge. Okay? Because naming molecular compounds is not the challenge. It's deciding that ionic and molecular first. Remember to make that decision. I'm not going to talk about how to go the other way. We're just going to do some. So, diphosphorus pentoxide. So the element, for the first element is phosphorus, which is P. It says di, so there's 2 of them. The second element is oxide, O. Pent is 5, hex is 6. That's it. I told you the name was going to be 3 carbons, 8 hydrogens. That's what the names end up being. We just use prefixes. Okay, so tetraiodine non-oxide. That does not mean that tetraiodine is not an oxide. It says non-oxide. Okay, iodine, tetra, oxide, nana. I'll have none of that. These are really easy, right? Give me lots of these on the test, Mr. Green. Make the whole test this. Sulfur hexafluoride. Fluoride, F. Hexa, 6. Nitrogen trioxide. Nitrogen, N, tri. That doesn't mean to give it a shot. Trioxide means 3 oxygens, right? Okay. Notice it's not nitrate. Nitrate has a charge when it does this. Right? Nitrate is NO3 with a 1 minus charge. It's not an ion unless it has a charge. Carbon tetrahydride. See? Hydride must be talking about hydrogen, right? See, we ran into that yesterday when naming, when hydrogen's acting like a nonmetal. We stick that "ide" ending on it. Hydride. And tetra means 4, CH4. Methane. Phosphorus trifluoride. P. P and then 3 Fs, because that's what it says in the name. Aluminum chloride. And you're going to go Al, and then you're going to go Cl, and then you're going to write a 3. Because you skipped the first step again. Aluminum's a metal. Aluminum's a metal. Since aluminum's a metal, I got to worry about charges. Al's 3 plus. Cl's 1 minus. They don't add up to 0. AlCl3. So from the name, the way you recognize that it's ionic, or that it would decide between ionic and molecular, is the second word. If the second word has a prefix, it's molecular. If the second word does not have a prefix, it's not molecular. If they don't tell you how many of the second element, they expect you to figure it out. Okay? So you got to decide whether that thing in front is a metal, right? That's one way to decide ionic and molecular. Or if you look at the name, the second name, if it's got a prefix, it's molecular. If it doesn't have a prefix, now there's only one slight part of confusion. That would be things like dihydrogen phosphate. That prefix doesn't count as a prefix for, because that's part of the ion name, and dichromate. That could show up there. Because dichromate is a polyatomic ion. And it ends in 8, so you would know it's not molecular anyway. Okay? All right? So that's what we got today. Okay. So it starts off with everything separated and has you practice separate things, and then it mixes them all together. Okay? Because first we show we can do them while they're separate, then we do them while they're together. That seems like a reasonable way to approach it, doesn't it? Since make sure I can do it, then make sure I can do both kinds, and then I can make sure to decide which kind to do.